Okay. So anyway, that's the end of chapter 3, right? That's the end of chapter 3. Let's talk about chapter 4 now for a few minutes. Okay, so chapter 4, I would say, is a more technical chapter. And really, in chapter 4, which is what we're going to talk about on Wednesday, in chapter 5, which we're going to do on Thursday, and so really the next 2 days we're going to be talking about bonds, right? Bond markets, what drives interest rates up and down. And in chapter 4, we're really talking about the mechanics of bond prices. Okay, so as I said, chapter 4 I would consider to be one of the kind of more detail-orientated chapters, right? As opposed to the kind of big picture, we're going to be kind of looking at the smaller picture. In this chapter, we want to talk about 4 different types of credit instruments, 4 different ways that you can make a loan. There's a simple loan where you lend money to somebody and they pay you back that principal plus interest. Okay, simple loan is simple. There is a fixed payment loan, such as most mortgages. Nobody here owns a house, so you may not know how a mortgage works. Maybe you do. Maybe you hear about this from your parents or whatever. How does a mortgage work? Anybody know? Yeah. Right. And every payment, every monthly payment is exactly the same. Okay. So if you have a monthly payment of $1,500, you pay that $1,500 every month for the life of the loan. So every payment has part of that is to cover interest, but some of that is to cover the principal too. So that when you get to the last payment, you pay off the end of your principal, that's the end of the loan, okay? That's called a fixed payment loan, right? And most, as I said, most mortgages are set up this way. Then there is a coupon bond. Coupon bonds are the way that corporate bonds and treasury bonds are set up. Okay, corporate bonds and treasury bonds are set up. Okay, a coupon bond has 2 fixed payments a year. So it pays twice a year. And at the end of the bond, it repays your principal, or what we will call the face value. So whatever the face value of the bond is, that's what you get at the end of the bond. Why a coupon bond? Well, a coupon bond, I'll try to remember tomorrow or next time I see you to bring one in. but it's a coupon bond because in the old days, the bonds were literally a sheet of paper, and at the bottom were these little tabs, and you would rip it off and send it to the company, and they would send you your check, right? So coupon bonds, because the little coupons are what you claim, they were basically claims to get your interest payments, right? So most corporate bonds, most treasury bonds are set up like this. Nowadays, there is no coupon, right? Nowadays, this is all electronic and you don't have to use the mail and all that kind of stuff. But the principle is the same, right? The principle is the same, that you get paid interest twice a year, and then at the end, you get the face value back. And then finally, the fourth is a discount bond, such as a T-bill. And we talked about this yesterday. What's the deal with T-bills or discount bonds? What's unusual about them?
T-bills are risk-free.
Well, they're risk-free, yes. But about discount, the fact that they're discount bonds, what does that mean?
Buy now, price below face value.
Exactly. There are no interest payments, right? There are no interest payments. You just pay a price less than face value. And so for each type of instrument here, these four types of instruments, we want to figure out what's the relationship between the price of these instruments. For instance, if you bought one of these, what price should you pay? And then the yield, and then the interest rate, okay? One of the things that we're gonna see is that for some of these instruments, the interest rate is not the same thing as the yield, okay? You can think about the yield as the return, but the return you get from some of these instruments is not the same thing as the interest rate. And we'll explain why that is, okay? So really, we're really talking about three different concepts as we talk through these. We're talking about price, how much you would pay for it. We're talking about the interest rate, which is also often stated. And then we're talking about the yield. Which is the true return. And oftentimes the return is to be determined, right, for reasons that we'll talk about. So right off the bat, one source of confusion in this chapter is don't get caught in the trap of thinking that the interest rate is the same thing as the yield, right? Or that the interest rate is the same thing as the return you get from holding a bond. Because we will talk about instances where they can be quite different. That the bond has a stated interest rate on it that's much different than the true return you get from holding the bond. Before we get into talking about the mechanics of how we figure out prices and interest rates and yields, let's just refresh our memory about present value, future value, because that's at the heart of all this. Right? You have all taken financial accounting, right? You've all taken, probably some of you have taken multiple finance courses. So my hope is that this is a topic that you feel like you're on pretty firm grounding with, right? We can all agree that $1 today is worth more than $1 tomorrow, right? And the reason is the interest rate, right? $1 today can earn interest. And as a result, $1 today is worth more than $1 tomorrow, right? Money is time, or time is money. That's a financial fact. So that makes $1 today worth more than $1 tomorrow, because $1 today can be put to work. dollar today has time, right? And it can be invested in ways that you can get a return from it. And so it is a fundamental mistake to add dollars across time. You cannot do that, right? In finance, you cannot add dollars across time. I cannot say, you know, sorry about using the sports analogy, but this guy signed a 2-year, $20 million contract that pays him $10 million this year and $10 million next year. Sorry, but that's not $20 million contract, because $10 million a year from now is not worth $10 million today. You just can't add $10 million today to $10 million a year from now and say it's the same thing, right? You can't. Now, we do it, right? But it's wrong, right? And it's giving you a misleading picture about what's going on, right? A lot of sports contracts take advantage of this, right? They know that the player wants to say, oh, I got this $100 million contract, right? But then what happens when you look at the details of the contract? A lot of that money is 3, 4, 5, 6, 7, 8 years out in the future, right? So it's worth a lot less than today's dollars, right? But by just kind of adding up the value of the contract, you're getting a really misleading view about what's going on. So how do we correct for this? Well, we correct for this by taking account for the fact that money loses value at the rate of the interest rate, right? It loses value at the rate of a nominal interest rate. So we have to discount future dollars back to today's dollars, right? So if I have a dollar in the future, well, let's do it this way. If I ask, what's a dollar today worth a year from now? You would say, well, you take that dollar and you multiply it by 1 plus the interest rate. And that tells you what it's worth a year from now. That gives you the future value of a dollar. So if the interest rate is 10%, what's a dollar worth today, a year from now? $1.10, $1.10, right? What's it worth in 2 years? Well, we would take that whole thing and multiply it by 1 plus I again, right? Or we could simplify this down, right, to 1 plus I, $1 times, not plus, sorry, 1 plus I to the second power, right? That's the future value of $1 in 2 years. And then kind of extending this analogy out, what's the value of $1 in n years? One plus I to the nth power, okay? So we can take a dollar today and move it forward in time to calculate what its future value is going to be. And then, of course, we can work this backwards, right? Just as we can move money to the future, we can take future dollars and move them back to today. What's the present value of a dollar? What's the present value of a dollar, something that's worth $1 a year from now? Well, instead of multiplying by 1 plus I, we just simply divide by 1 plus I. And once again, expanding it out to n years, what's the present value of $1 n years from now is just 1 divided by 1 plus I to the nth power. So this is at the heart of everything we're doing, particularly working from future value to present value is at the heart of what we're doing, right? If I'm thinking about a bond and purchasing a bond, what do I know? I know all the future payments. The bond tells me what my interest payments are, and I know what the face value is. I know all the future payments. What don't I know? How much I should be willing to pay for the bond today. But I can use this principle of future value to kind of figure out what the present value of all those future payments are. That will give me an idea of how much I want to spend on the bond. Once again, remembering that we cannot add dollars across time, right? Because that leads to really important mistakes, right? So this is where yield to maturity comes in. Yield to maturity is a way to measure the return on holding an asset. Okay. Yield to maturity is a measure of the return on holding an asset. Okay. And specifically, how do you calculate the yield to maturity? This is a mouthful. I'll write it up there and then I'll explain it. The yield to maturity, how you calculate it, is you're essentially calculating the true interest rate that equates the current price of the asset with the present value of future payments. It's a measure of the true interest rate that equates the current price with the present value of future payments. Okay? The easiest way to understand yield to maturity is to do some examples of calculating it, right? I think doing some examples, you'll hopefully begin to kind of see what we mean by equating the current price with the present value of future payments. So let's talk about those 4 instruments that we've talked about. Okay, let's calculate the yield to maturity on a simple loan, on a fixed payment loan, and maybe on a coupon bond if we have time. We probably won't get through all 4, but we'll at least do a couple of them here. Okay, a simple loan, right? Let me give you an example. start with a really, really simple example. What's the yield to maturity on a simple loan of $100 that requires a payment of $108 a year from now? So a 1-year loan of $100, a year from now you have to pay back $108. Okay, how do we figure this out? Let's go back to what we wrote. The yield to maturity is the true interest rate that equates the current price with the present value of future payments. Okay? What's the current price? $100. Today, you get $100. What's the present value of future payments? Well, what do you have to pay in the future? 108. How do we turn that into a present value, though? 1 plus I. And because it's just a 1 year, right? N is just 1 there, making it very simple. What is I? Yeah, it's the true interest rate. In this case, it's actually just the interest rate, right? But in this example, I don't think you need a calculator to get this, right? I is 8% or 0.08. Okay. One of the nice things about a simple loan the yield to maturity is the same thing as the interest rate. The yield to maturity is the same thing as an interest rate for a simple loan. So here's an example where, yeah, the interest rate and the yield to maturity are the same. But as I said, for different kinds of instruments, the interest rate can be different than the return, right? Just remember that. We'll come back and look at a couple of examples here in a minute. Okay, let's talk about the second type, a fixed payment loan. What's the yield to maturity on a loan of $1,000? What's the yield to maturity on a loan of $1,000 with yearly payments of $126 for 25 years? So in other words, if a bank would be to enter into this kind of loan, what is their yield to maturity? What's the measure of the true return that they would get? So what's yield to maturity again? It's a true interest rate that equates the present value, or it equates the current price with the present value of future payments. So what's the current price? 1,000, right? That's what you get today. What's the present value of future payments? Well, what do you pay at the end of the first year? 126. We have to discount that back though, right? By 1 plus I to the first power. What about the second year? Same thing. But now we have to discount this by 1 plus I squared. It's 2 years. What about the third year? The third, all the way out to the 25th year. And remember, it's a fixed payment loan. So the last payment is it. There is no balloon at the end, or you don't pay back any principal. You've been paying principal back all the way along. So what is the yield to maturity here? It's the interest rate that makes this true. It's the interest rate that makes this true. Now, how do you solve for this? Here's the problem. If it was like one payment or two payments, you can actually solve this by hand. But with 25 payments, it doesn't have a closed form solution. In other words, you can't solve this by hand. What do you have to do? You have to use a financial calculator, right? You have to use a financial calculator. Either a calculator or there are websites. I will link you to a couple of websites on your homework where you can actually just plug in the information and it will solve for you. But what the calculator is doing is it's solving this equation, right? And how it's solving it is it's doing just basically plug and chug, right? It tries different interest rates until it finds one that works. If you plug this into a financial calculator, you'll find that the yield to maturity is 12%. Right? That's the interest rate that makes this true. Okay. Okay, let's talk about a coupon bond. This one gets a little bit more complicated. Right. This one gets a little bit more complicated. So, remember the deal with the coupon bond. Coupon bonds pay semi-annual, right? They pay every 6 months. These bonds they have a face value. Right? They have a face value and they have a coupon rate. Which is the interest rate. And then they have a coupon payment. And what's the coupon payment? It's basically the interest rate times the face value, but divided by 2, because you get 2 payments a year. But the key to all this is that these bonds can sell at something different than their face value. These bonds can sell at something different than their face value. And as a result, the yield to maturity can be greater or less than the coupon rate. Right? The coupon rate will not tell you what the yield to maturity on these bonds are because the price that you bought the bond might be different than what the face value of the bond is. So that is one complication here. There's really 2 complications to the coupon rate. One complication is this, that the price could be different than the face value, but there's also this other complication. And by the way, this is a complication that in your book, they don't talk about, and I've never quite understood why Michigan doesn't talk about this. But the other complication is this. You don't get just paid once a year, you get paid twice a year, right? So how do we adjust, right? How do we figure out the yield to maturity? Well, once again, we have to figure out, the interest rate that equates the present value, the current price with the present value of future payments, right? But we have to be very careful at how we think about future payments, right? We have to be very careful about that and how we discount those back. So, what's the current price? Let's do an example. Let's see. So you see this bond out there. It's a 10-year coupon bond with a face value of $10,000 and a 10% coupon rate. But it's selling for, I don't mean 900, I mean 9,000. So what do we notice here? The price is selling for less than the face value, right? The price is selling for less than the face value. What's going to be the coupon payment every 6 months? %10 times 10,000, right? It's a percent of the face value, not the price. And we divide that by 2. So every coupon payment is $500. Every coupon payment is $500. So every 6 months you give a coupon payment, okay? So now the calculator, set up our equation to calculate yield to maturity. What's the current price? 9,000. Okay, what's the present value of future payments? This is where it gets a little tricky. Well, what do we get at the end of 6 months? 500. What do we have to discount this back by? Well, notice here that now we have it's only 6 months, it's half a year, right? So there's a couple of different ways that we could do this, but I think the one to me that's most intuitive is to really think about this. Oh, I didn't write this down here. I'm sorry, there's one piece of, that was bad. Sorry, 20 years to maturity. No, 10 years. 10 years. We need to also know how long to maturity, right? 10 years to maturity. So I think the most intuitive way to set this up is if it's 10 years to maturity and we get paid every half year, how many periods are there really? 20 periods. 20 periods in which, right, the annual yield to maturity is just divided by 2. Does that make sense? Because it's half a year's yield to maturity. So at the end of 6 months, we get this. What do we get at the end of the year? That, right? There's 1 year. What about year 2? right? All the way out. What's year 10 going to look like? In the middle of the year, you get one payment. Payment 19. And then what does payment 20 look like? What does payment 20 look like? What do you get at that last payment?
The 40 power?
It would be, 10 years. This part would be the 20th. What do you get in that last payment?
Principal amount.
You get the principal back. You get the principal back, the face value. Not the price, the face value. That's year 10. So what's the yield to maturity? The annual yield to maturity is I. Right? It's the annual yield to maturity. How do you solve for this? Well, once again, for a complicated one like this, you really can't solve it by hand, right? You really have to use a financial calculator, right? You really have to use a financial calculator where you tell the financial calculator it's a semi-annual bond, as most coupons are, and you have to give it the years to maturity, and you have to tell what the price is and what the face value is, and then you calculate the yield to maturity. In this case, when you calculate the yield to maturity, you'll find that the yield to maturity is 11.75%. Wait a second. I thought the coupon rate was 10%. What happened? How did I get a return of 11.75% when the coupon rate was only 10%?
Just paid the $1,000, which was the price you bought it at, and
Right. The price was less than the face value, right? So I paid $9,000, but what do I get out here at the end? $10,000. That increases my yield. I essentially get an extra $1,000. And it's that extra $1,000 that increases my yield. So you can't, for a bond, you can't just look at the interest rate alone and know what the yield is. You also have to incorporate any difference between the price and the face value, right? You have to incorporate that. Specifically, in this example, if the price is less than the face value, then what can we say? If the price is less than face value, then what's true about the yield to maturity? It's greater. What happens if the price would be greater than the face value? What's true about the yield to maturity? Right. And what happens if the price is equal to the face value? Then they're the same. So the only time that the yield to maturity is equal to the coupon rate is if the price is selling at the face value. okay? So if this seems a little confusing, a little black box-ish, look at it tonight. But let me try to give you intuitively maybe a picture of what's going on here. I think when people get confused about the yield to maturity and the coupon rate, what they're really confusing is the fact that the coupon rate is put on a bond when the bond is first issued, right? It's put on historically. Right? The yield to maturity, though, reflects what the market thinks that bond should be worth, right? The yield to maturity is reflecting what the market thinks that bond should be worth. So let's say that we have a bond, a $1,000 bond that sells at face value, okay? And let's say its coupon rate is 5%, right? So its yield to maturity is expected to be 5%, okay? So the bond sells at face value, somebody buys it, they're holding it, and then something happens in the economy and interest rates go up, right? Interest rates on all bonds go up, including bonds that are very similar to the one that you're holding. Now, what happens if I want to sell that bond? Am I going to be able to get the face value for it? No, because somebody else can go out and buy another bond that gives them a higher return. The market now says that my kind of bond has to give a higher return. How do I give the next bondholder a higher return? I have to lower the price, okay? So basically, you know, what we see here is what's known as the law of the bond market. And the law of the bond market is when market interest rates go up, bond prices have to go down on secondary markets. So when interest rates go up, bond prices on secondary markets have to go down. Because what happens when bond prices go down? What happens to the yield to maturity? That goes up. So when market interest rates go up, the yield to maturities have to go up too. How do yield to maturities go up? Bond prices have to go down. All right? That's the mechanics of this, right? That's the mechanics. And so, yeah, we'll talk more about the law of the bond market tomorrow. But this is like a confusing thing, I think, a little bit. Because you think, well, doesn't higher interest rates make bonds more attractive? Well, it only makes new bonds more attractive. Existing bonds, it actually makes less attractive because they have lower coupon rates. So if you have to sell them, you're going to have to sell them at a lower price, right? You're going to have to sell them at a lower price. So whenever market interest rates rise, yield to maturities have to rise, and that means that bond prices have to fall, okay? That means that bond prices have to fall. So this kind of seems like maybe a pretty good place to stop. Actually, just getting through this, for the homework that I will send you here in a couple of minutes, you actually can work through the first few problems on this, right? We actually got a fair amount of the way. So when we meet tomorrow, I'm going to send you a couple of videos. It's actually going to be on some of the stuff that's at the end of chapter 4, because this is the stuff I really want to talk more in person, because I think we kind of have to have a little interaction about this, because it's a little bit more confusing. So I will send you a couple of links that will have some stuff toward the end of chapter 4, and also talk about microfinance. And then hopefully when we meet tomorrow afternoon, we'll kind of pick up here. We'll kind of review this, and then we'll talk about the fourth kind of instrument, which is a discount bond, right? How do you price those? And then we'll talk about some other measures of return, right? Because yield to maturity is not the only way that you can measure return. There's other ways out there. And so we'll talk about those, and hopefully those will kind of give us some insight into what's going on, okay? All right, thank you very much. Have a great afternoon, and hopefully I will see you some way, shape, or form tomorrow afternoon.